And let me check that. So I will take a problem about, let's say a long spring, and long mean a couple of meters. And that spring is heavy, and I'm holding that spring at this point, like this. Okay. So that's me holding the spring. And since the spring is heavy, it's going to stretch. And I'm interested in the length of the spring. If I know the original length of the unstretched spring, what would be the stretched spring? What's the length of it? Okay, complete the picture. Now this is a complete problem. So, the first question for you. Would you think an integral might be useful? And then if yes, then in trying to set up the integral, what kind of information do you need to know? I'm not going to give you the standard textbook problem. Given this, given that, combine all the given information to come up with the answer. It is typically that you look at the problem and you request information and you decide which information is important and which information is irrelevant. And usually, whatever you want, you will get. You want to know original length of the spring? I will give you. You want to know anything else? I will give you. Everything will be given upon your request. So, what is it that you want to know?
Tension? That's not tension. It's K value.
K value. K, constant, right?
No, it's one that shows the amount of force required to stretch it for 1 meter. Whatever it is.
So constant.
Yeah, it is constant.
So say again, what is it responsible
for? It's the amount of force required to stretch the spring for 1 meter.
Of force needed to stretch the spring by 1 meter. Okay. Well, of course, we're talking about one spring, not about multitudes of springs. So, for one spring, is that really a constant? Amount of force needed to stretch it by 1 meter, to make it 1 meter longer. Really? Does it depend only on the quality of the spring and the amount you stretch by? You want to make it longer by 1 meter. And regardless of anything else, the amount of force needed is going to be exactly the same. I think so. Oh, think about this spring. Okay. 10 centimeters long. And you're stretching that by 1 meter. Right? And think about a spring that is already not stretched, but it's just very long. It's 2 meters long. and you are stretching that long spring, being unstretched originally, by 1 meter. Will you need the same force?
If they have same constant value.
No, I'm asking about the constant, right? What do you mean they have the same constant value? They are made of the same material. So this spring is exactly the same spring, just much longer. Right? And they are trying to stretch that very, very long spring. So you're stretching that, and you're stretching this. You'll experience the same force. No? Well, if not, then one is greater than the other. Which one is greater? For the smaller spring? For the shorter one?
You can't stretch this one.
Well, assuming you can. Assuming it's really long, just very condensed. And this is also very condensed, right? Assuming you can physically stretch it. Will you need the same force, or will you need greater force to stretch shorter spring? You'll need greater force, right? Because you will see the spring after you stretch it. So what's going to be the resulting stretched spring? Well, the short one, you will see it like that. Very, very stretched at every point. And the long one, well, will be stretched, but just a little bit. Right? So, don't you think that the force needed to stretch that, well, to stretch to this state, needs to be greater than the force needed there? So that may not be a constant. And if that is not a constant, then what is the constant? If that amount so far depends on the length of the spring, not only the quality of the spring, right? How to get rid of that dependence? How to make a quantity here that depends only on the quality of the spring?
Mass.
Mass? Mass of the spring? And the length? What about the length? So what should we do with the length? If the short spring produces large force and the long spring produces small force, how should we modify this description to get a constant as a result?